Mathematics Wizard here, and I am back in action. In this two-part video, I will be showing you how to solve a system of equations using the two following methods: elimination and substitution. And as you can see, there are my table of contents. So part 1 of this video will be about solving systems of equations in two variables, and part 2 will be about solving systems of equations in three variables. So with all that being stated, let's get to work. So let's say you had a system of equations of x plus 5y equals 0 and x minus 5y equals 20. Now, you have to determine which method to use based on what's given to you. And in this case, you're going to use the method elimination. And the way this works is that you want one side or one variable on each side to result in 0. And in this case, you see that both 5y and negative 5y result in 0. So the y's are automatically gone, and all you have is 2x equals 20, because you're simply just adding up the x's to get 2x, and you're just adding 0 plus 20 to get 20. Now you evaluate to get x, and so you know you have to divide 2 on both sides, and x equals 10, so that goes in the x spot. And now to get your y, of course you have to plug x back into both equations to make sure that you get your y value and to confirm their authenticness. So plugging x back into the top equation, you'll get 10 plus 5y equals 0. So you know that 5y has to be negative 10, because 10 plus negative 10 is 0, or 10 minus 10 equals 0. No matter how you say it, it's still the same. So you know that y has to be a negative 2 to make that a negative 10. Same thing for the bottom equation. You plug in 10 for x and multiply by negative 5 times negative 2, you get positive 10, so 10 plus 10 equals 20. Alright, let's try something different. Alright, next system of equations, you have y equals 9x plus 29, and 9x plus 5y equals negative 71. So basically in this system, you are dealing with a slope-intercept formula and a standard formula. And based on what they give you, automatically know that you have to use substitution. And the way this method works is that y is already given to you in the top equation. So what you're going to do is you're going to plug this expression into this y here. And this is how you do it. Just like that. And when you evaluate this, you get this. So what you do here is distribute that 5 into the expression of 9x plus 29 to get this full expression. 9x plus 45x plus 145 equals negative 71. And of course you see that 9x and 45x are like terms. So once you combine those, you'll get this. 54x plus 145 equals negative 71. And so, of course, you have to move the negative 145 to both sides of the equation, and you will get this. So, negative 145 and 145 cancel each other out, leaving you with negative 71 minus 145. You'll get negative 216, and set that equal to 54x. And of course you divide both sides by 54 to get this. You get x equals negative 4. And so you plug that negative 4 back into the top equation first to make sure that is correct. So 9 times negative 4 is negative 36. Negative 36 plus 29 gives you negative 7. So y equals negative 7. And if you want to check the bottom equation as well, you could, but most people would just check one equation and think it's okay straight off from the start because, you know, they are like more confident at doing things. And I understand if some of y'all are those people who want to check everything to make sure it's correct. That's fine. Whichever way is easy for you, you can do that. So you can also check the bottom equation to make sure that it's correct and it equals negative 71. So negative 4 times 9 is negative 36. And that negative 7 you plug in for y. So 5 times negative 7 is negative 35. So that will be negative 36 minus 35 because 5 times negative 7 is negative 35. So that's going to be minus 35 gives you negative 71. And so we know our solution is true, therefore the solution to the problem is negative 4, negative 7. Alright, let's try another one. Alright, so let's say you had a system of equations of 8x plus 3y equals negative 40 and 7x plus 5y equals negative 16. Now, unlike the first example on elimination, it was given to us. In this one, it's not given to us because now, using the elimination method, we have to figure out which variable we want to get rid of and which equation we want to keep and which equation we have to multiply by depending on the variable we've chosen. So let me tell y'all something. Now, with this example, you could do either one or two things. You could use substitution and try to solve for y in one of each equation, or you could do a much faster way, elimination, and just get it over with. So we'll stick to the elimination process because with standard forms like this, I find it easier to do elimination, so we'll do that. Now, depending on what variable we want to get rid of, I'll choose to get rid of the x's. Now, I'm going to keep my bottom equation the same, and to make this 8x negative 7x, we have to multiply by negative 7/8. And here is your new equation when you multiply this whole top equation by negative 7/8. Negative 7x minus 2 and 5/8 y. Sorry, let me do that very quick. There we go. Alright, so once again, negative 7x minus 2 and 5/8 y equals 35. Now it's easier to see that the x's are gone because negative 7 and 7 are additive inverses, meaning that opposites always result in 0, so those are gone. And now all we can do is focus on the y's, and this is what you'll come up with. 2 and 3/8 y equals 19. And of course you're going to divide 2 and 3/8 on both sides, and this is your solution for y. It is y equals 8. Now, you're going to simply plug that back in to the two equations to confirm that they equal 35 and negative 16. So we'll start with the top. So, negative 2 and 5/8 y will become negative 21 because 8 times negative 2 and 5/8 equals negative 21. So, now we know that something minus 21 has to equal 35. So we know that negative 7x has to equal 56. because 56 minus 21 equals 35. And to make negative 7x 56, x has to equal negative 8, because negative 7 times negative 8 equals a positive 56. Therefore, we know that the top equation is true, because it equals 35. Now we're going to go to the bottom equation and plug in 8 for that y. 5 times 8 is 40. So we know that something plus 40 has to equal that negative 16. And that number we want is negative 56, because negative 56 plus 40 is negative 16. So we know that that bottom equation is also true, therefore our solution is true. Negative 8, 8 is our solution. Let me just fix that, and there we go. Negative 8, 8 is our solution. Alright, let's try another one. Alright, next example, we have y equals 7x plus 33, and 2x plus 5y equals negative 57. And obviously we know we have to use substitution because our y value is in front of us. So all we got to do is take this top equation, its expression right here, and plug it into this y. And here's what you get. 2x plus 5 brackets 7x plus 33 equals negative 57. Now, when you distribute that 5 into this expression in brackets, this is what you get. 2x plus 35x plus 165 equals negative 57. Like terms, combine them, and this is what you get. 37x plus 165 equals negative 57. Negative 165 on both sides. Additive inverses cancel, and this is what you are left with. 37x equals negative 222, and x equals negative 6. So now that you have negative 6, plug that back into the two equations above as so. So negative 6 times 7 is negative 42. Negative 42 plus 33 equals negative 9. And like I said, you can check the bottom equation to make sure it's true as well. So when you plug negative 6 in, you get negative 12, and negative 12 minus a 45 equals negative 57. So to make 5y negative 45, of course you would plug negative 9 in for y, and you get negative 45. So together you will have negative 12 minus 45 equals negative 57. So we know our solution is true. Alright, let's try one more for this part. Alright, so now we have x plus 2y equals 0. And x minus 2y equals 32. And what do you know? It's given to us that we have to get rid of the y's because negative 2y and 2y automatically result in 0, so they're gone. And we are left with 2x equals 32 and x equals 16. Now, we plug that 16 back into the equations above. So starting with the top one, 16 plus some number gives us 0, so we know that an additive inverse, which is negative 16, has to give us that 0. And so 2y equals negative 16, and we would know that negative 8 times 2 is negative 16. Therefore, we know that y equals negative 8. Now, check the bottom equation. You have 16 minus what number gives us 32. So we know that 16 minus negative 16 or plus 16 gives us 32. So negative 8 times negative 2 would make a positive 16. So you'll have 16 plus 16 equals 32. So we know our solution is true. Alright. Alright, now, so we are currently moving into part 2 of this video, and this is dealing with solving systems of equations in 3 variables. Now, let's say we had a system of equations of x minus 4y plus 3z equals negative 27, 2x plus 2y minus 3z equals 22, and 4z equals negative 16. Now, straight off the bat, we can easily solve for z and see that z equals negative 4 because 4 times negative 4 equals negative 16. Okay, so now you have negative 4 equals your z. Now, what happened here is that 3 times negative 4 is negative 12, which is why you see this negative 12 here. Oh shoot, sorry. Let me go back. Yes, this is why you see negative 12 here, because recently there was a 3, and that z we plug in for negative 4 made it negative 12. Now, the bottom one, this had a negative 3 already, so a negative 3 times negative 4 made it a positive 12. So they kind of like swap places because one was positive and one was negative, but putting that negative in for z made it look like it swapped places, so it's kind of funny there. Alright, so as I was saying, so you replace those with negative 12 and positive 12. And now, just like we did before with solving equations in 2 variables, you pick which variable you want. So I'm going to pick the x's. So therefore, I want to keep that top equation the same, and we're going to multiply this bottom equation by negative a half, because negative a half of 2 is negative 1, because we want this x to be a negative x. So we can keep that x on in the top equation. So this is what happens to your equation. This will be your new equation. So your new equation is negative x minus y minus 6 equals negative 11. So as you know, negative x and x cancel out, and we're left with negative 5y minus 18 equals negative 38. And what do you know? We have to bring 18 to the other side. And we are left with negative 5y equals negative 20. And of course you see that y equals 4. Now, to figure out what x equals, all we have to do is plug 4 back in for the y you see to confirm that they both equal negative 27 and negative 11. So for the top one, when we plug in 4 for y, this becomes a positive 16. So you have 16 minus 12, wait, excuse me, negative 16 minus 12 is negative 18. So now you know that's negative 18. Now you have to figure out what x will equal to get you that negative 18. X, sorry, I meant now you know that that is, sorry, it's negative 28. My mistake, guys, negative 28. You have negative 28, and so you have to figure out negative 28 plus what number will give you negative 27. And so you know that answer is going to be 1, because a negative 28 plus 1 is a negative 27, so we know that is true. Now, if you want to check the bottom equation, you can. You plug in y, you replace y with 4, you get negative 4 minus 6 is negative 10, and negative 10 minus that 1 is negative 11. So we know that our solution is true. 1, 4, negative 4. That is our solution, so we know that is true. Alright, let's try another one. Sorry for the errors, by the way. I hope y'all understand it as I am mentoring this. Alright guys, let's try another one. Okay, so x minus 2y plus z equals negative 1. Negative x plus 2y minus z equals 6. Negative 4y plus 2z equals 1. Now, as you can see, there is no giveaway this time, because these are all like equations that are not like simple, like the last one we did in the previous few examples where we had 4z equals negative 16. Yeah, that you will not see very often, because technically when you're dealing with solving system of equations in 3 variables, you have to pick 2 equations to do first, solve those terms, and bring the third one in later. So in this case, I'm going to start with these two and bring in negative 4y plus z equals 1 for later. Because if you look, you can see that the x's, the y's, and the z's are all additive inverses of each other. So whenever that happens, that's an automatic 0. Now on the right side, that equals 5. But there's an incorrect error here. Sorry. There's an error here, because 0 never equals 5. Therefore, we have no solution. No solution. Because whenever all 3 terms are additive inverses, that automatically tells you that we have no solution here. So, really, there is really no reason to even bring in this equation, because what we just discovered with the top two, we have no solution, because all 3 variables are additive inverses, depending on their coefficients and symbols, the signs, the positive and the negative. So there's really no sense in bringing this, because we already know that there's no solution. So therefore, we have an inconsistent equation here. Alright, let's try one more. Alright, we now have 2x minus 5y minus 3z equals 7. Negative 4x plus 10y plus 2z equals 6. And 6x minus 15y minus z equals negative 19. So once again, pick any two you want to work with. It does not matter how you do it, you will always get the same answer. So I decided to do these two and bring in negative 4x plus 10y plus 2z equals 6 in later. Alright, let's get started with this. Alright, so now I'm going to get rid of the y's this time. So I'm going to keep my top equation the same, and I'm going to alter the bottom equation. So in order to make 15y a positive 5y, I'm going to multiply by negative 1/3. And this is your new equation once you multiply by negative 1/3. Alright, we have negative 2x plus 5y plus 1/3 z equals 6 1/3. Alright, now as you can see, our x's and y's are gone at the exact same time, because we have additive inverses. So those two are gone. And now we can deal with the z. So this is what you get. You get negative 2 2/3 z equals 13 1/3. So of course you would divide both sides by negative 2 2/3, and then you will see that z will equal negative 5. Alright, now we have a negative 5. It's time we bring in the middle equation, which was negative 4x plus 10y plus 2z equals 6. And of course I made a little footnote letting you know that that used to be a 2z right next to the 10y, but we already found our z. It was negative 5, so all we do is multiply that by 2, we get negative 10. So that's why you see that there, just in case y'all get confused there. Alright, so now this time I'm going to get rid of the x's. And this time I'm going to keep my hold on. Okay, I'm going to keep my top equation again the same and only deal with the bottom one. So of course, now to make this a negative 2x, all I have to do is multiply by a half. And this will be your new equation. Okay, so you get negative 2x plus 5y minus 5 equals 3. So we know that the x's are gone, but hey look, our y's are gone too. But look, if you notice, we result in 10 equals 10. Now, whenever this happens, when you have a number equal to another number, the result is going to be infinitive, meaning it's going to be infinitely many solutions. Now, infinitely many solutions. What this means is whenever you have, for example, 10 equals 10, 1 equals 1, anything like that, you result in infinitely many solutions. So you could, for example, we found z, it was negative 5, but when we kept going, because we had to input that middle equation in, we found out that our x's and y's were gone as well, and we were left with the same thing, 10 equals 10. Whenever something like that happens, you have infinitely many solutions. Alright, well guys, that is all for today. If you like this video and if it was very helpful, please subscribe, leave a like, and a comment in the comment section. If you need anything more detailed at all, I'll be happy to give it to you. Thank you very much. I am out.